Greetings, this is Ishraq Hayat, and I'll be presenting my individual race training strategies and evaluation metrics for my DeepRacer. For the final competition, we had the reInvent 2018 track, so this is the track that I chose for training my models. This track was relatively simple, but there were a few turns that required careful training. My training was based off of the strategy of raceline. So the raceline concept reduces the path length to optimize the performance of the DeepRacer. I have used a proportional error-based reward function, which simplifies the reward function and is very powerful to model the whole track. I capitalized on hyperparameter tuning by progressively increasing the focus of the DeepRacer during the different training cycles. Here's a glimpse of the 3 different iterations of hyperparameter configurations. From here we can see that the gradient decent bat size is 128. I selected this for optimum training stability and speed. I progressively reduced entropy throughout the different iterations to improve exploitation and reduce exploration and variance over time. I've used a discount factor of 0.99, which means that I'm using 100 look-ahead time steps, and this was appropriate for this track given the track simplicity and the waypoint configuration of the track itself. I chose the loss type to be Huber because it gives better convergence. Learning rate has been progressively reduced for improving convergence. I have progressively reduced the number of experience episodes to improve the training time, and to reduce overfitting. And then the number of epochs for each episode was selected to be 10, which was the default. The reward function is pretty simple. I am giving a reward of 0 if the racer goes off track. Otherwise, I'm starting from a baseline reward value of which is equivalent to the progress, and then I'm rewarding the racer 3 times every time it is on the race line. And otherwise, if it goes off of the race line, then I'm rewarding based off of how close the racer is to the race line by taking the inverse of the difference between the race line direction and the racer's direction. I'm using the TensorFlow framework with the proximal policy optimization learning algorithm. So PPO is simpler and faster to train, and it focuses on improving based off of policies that are closer to each other. Here are 3 iterations of my reward function graph. So we can see progressively we get improved completion rate. However, in some cases, I did face convergence issues, at which point reducing the learning rate definitely helped. So here's evaluation. I came out to be 11th on the DeepRacer competition, and here's a glimpse of a few evaluation metrics. So I have been able to achieve 100% track completion at times. If not, then they have been mostly over 50%. So what I've realized and observed by training this time was that progressively reducing the different hyperparameter entities like discount factor, learning rate, experience episodes, and even entropy has the potential to provide stellar performance over time if we have a simple reward functions, because that's simpler for the racer to learn. And possible next steps for me would be to explore other avenues of reinforcement learning, possibly in gaming and finance, and just to go beyond DeepRacer. Here are a few resources that I made use of, and I'll be providing the YouTube link eventually. Thank you.